ओके बेटा, तो ये जो आज करने वाले हैं हम एल्डोल एंड कैनिज़ारो रिएक्शंस, इट इज दीज आर द रिएक्शंस ड्यू टू द अल्फा हाइड्रोजन्स। अब ये क्वेश्चन है कि ये अल्फा हाइड्रोजन एक्चुअली होते क्या है। तो कीप इन माइंड कार्बन विच इज अटैच टू सीओ, देखो ये सीओ ग्रुप है, सी डबल बॉन्ड ओ ग्रुप से जो डायरेक्टली अटैच कार्बन होता है उसको बोलते हैं बेटा अल्फा कार्बन, and hydrogen attached to that alpha carbon is called alpha hydrogen। अब ये अल्फा हाइड्रोजन है, ये इतनी इंपॉर्टेंट क्यों है? तो बेटा अल्फा हाइड्रोजन इसलिए इंपॉर्टेंट है क्योंकि जो सी डबल बॉन्ड ओ है, टेल मी वो कैसा ग्रुप है? इलेक्ट्रॉन रिलीजिंग ग्रुप है कि विड्रॉइंग? सी डबल बॉन्ड ओ जो है वो कार्बन से इलेक्ट्रॉन को विथड्रॉ करेगा या कार्बन की तरफ रिलीज करेगा? देखो ऑक्सीजन और कार्बन में विच वन इज मोर इलेक्ट्रोनेगेटिव? विच वन इज मोर इलेक्ट्रोनेगेटिव आउट ऑफ कार्बन एंड ऑक्सीजन? यस बेटा, आउट ऑफ कार्बन एंड ऑक्सीजन, yes, oxygen is more electronegative than carbon, so that's why oxygen withdraw electron from carbon, so carbon in turn withdraw from another carbon. So in this way what will happen? This carbon in turn withdraw electron from hydrogen, and therefore hydrogen can be eliminated in the form of H plus. So that's why this alpha hydrogen is acidic. So these reactions are due to the acidic nature of alpha hydrogen. See, aldehydes and ketones undergo a number of reactions due to the acidic nature of hydrogen. Now, when this hydrogen is removed, what will happen? You know, hydrogen is removed as H plus. So this carbon acquire negative charge, and as it acquire negative charge, so it becomes like this, right? So in this way, you know, this lone pair is in conjugation. So this acidity of alpha hydrogen atoms of carbonyl compounds, it is due to the strong electron withdrawing effect of the carbonyl group and resonance stabilization of the conjugate base. The resonance stabilization of conjugate base. This conjugate, see, this becomes acid because it gives H plus ion. After removal of H plus ion, it becomes its conjugate base, and this conjugate base is resonance stabilized. As it is resonance stabilized, that means H plus ion removal is easier because anion becomes stable. So in this way we can say that these reactions of aldehyde and ketones are due to the acidic nature of alpha hydrogen. Why not beta hydrogen or gamma hydrogen? Because if we remove alpha hydrogen, then only, let us say like this, these are three cases. So first of all we remove hydrogen from alpha position. Next, we remove hydrogen from beta position. And third, we remove hydrogen from gamma position. Alpha, beta, gamma. Alpha, beta, gamma. So tell me, which lone pair is in conjugation with pi bond? Only alpha hydrogen. Lone pair on alpha hydrogen, that is in conjugation with C double bond O. With beta or gamma, it is not in conjugation. So it means this one is resonance stabilized. That's why all the reactions are involving alpha hydrogen. See, acidic nature of alpha hydrogen is responsible for the reactions. ये बेटा इतना पॉइंट क्लियर हुआ आपको?
सर ये वाला फिर से एक बार समझा लीजिए ना, जो रेजोनेंस स्टेबलाइज जरा समझ नहीं आया।
एक्चुअली बेटा C double bond O. Conjugation means when lone pair and pi bond are separated by a single bond. Only one single bond is there in between pi bond and lone pair. See, this lone pair become pi bond becomes lone pair. It is like this. Okay? ठीक है बेटा? So this lone pair and pi bond, in between them there is only a single bond. So that is called that lone pair is in conjugation with pi bond. Okay? And in this way there is delocalization. There is delocalization of lone pair. Right? Or delocalization of negative charge, we can say. So negative charge decreases due to delocalization, and therefore there is stabilization of anion. So if anion is stabilized, it is like this. H plus ion is removed and we get anion. If anion is stabilized, equilibrium shifts forward. If anion is stabilized, then equilibrium shifts forward. Now come to the aldol condensation. So those aldehydes which has at least one alpha hydrogen, which has at least one alpha hydrogen in the presence of alkali. So if we have alkali, so in the presence of strong acid, there is an acid base reaction. So again we get anion, because in the presence of base there is an excess of OH negative, and that OH negative ion abstract this hydrogen as H plus ion, we get this anion, and then this anion will attack on the another molecule and leads to the formation of beta hydroxyaldehyde. See, aldehydes and ketones having at least one alpha hydrogen, they undergo a reaction in the presence of dilute alkali as a catalyst to form beta hydroxyaldehydes or beta hydroxy ketones called aldol or ketol, and this is known as aldol reaction. See, how do we get it? Like this is ethanol, we get this product. How can we get it without going into mechanism? See, we have CH3CHO. Reaction is very important, beta. CH3CH double bond O. Write it like this. Now come to the second part of the same molecule. So this is alpha hydrogen. So keep two alpha hydrogens like this. Only see, alpha hydrogen should be in the front. So O and H2. There is a removal of H2O and we get CH3, CH, double bond CH, CHO. Okay, CH3, CH, double bond CH, single bond CHO. Done. So this is called alpha beta unsaturated aldehyde, or if it is ketone, then we call it as ketone, alpha beta unsaturated aldehyde or alpha beta unsaturated ketone. So let's write ketone. This is ketone. So in the first molecule we write it like this. Then second molecule, this is alpha, it is again alpha, you can write any one. Or you can write it same, simple like this. So O and H2. Remove it. CH3, single bond C, single bond CH3, double bond CH, single bond C, double bond O, and CH3. Okay. Done? See, alpha, beta. So this is the final product actually. See, in the both the cases, in the first case we get this product. In the second case we get this product. So final product we can get, this is called aldol condensation product. First we get beta hydroxyaldehyde, beta hydroxyketone, and this name aldol derived from the names of the two functional groups, aldehyde and alcohol, present in the products. The aldol and ketol, they readily lose water and give alpha beta unsaturated carbonyl compounds, which are aldol condensation products, or reaction is called aldol condensation. Though ketones give ketones because they contain keto and alcohol group, but the general name aldol condensation still applies to the reactions of ketones due to their similarity with aldehydes. I hope you understood it. Yes, beta.
Yes, sir.
What about Anu? Yes, beta. Got it?
Yes, sir. Yes, sir.
Okay. Now cross aldol condensation. Actually, aldol condensation means the aldehyde and second molecule is of the same aldehyde. But if we have two different aldehydes, like we have acetaldehyde and propionaldehyde, means ethanol and propanol. Now look, we have ethanol, we write it these two in this way. Now, first we write simple aldol condensation. So this is alpha. Here alpha is this one. Interesting to note. Alpha in first case we write two hydrogens of the alpha carbon or two alpha hydrogen in this way and we get this product in the presence of dilute alkali. Same in the second case. Tell me which hydrogens are placed in front so that they are removed. Yes, beta, tell me.
Which hydrogen?
Means we have alpha hydrogen and beta hydrogen. There is alpha hydrogen, beta hydrogen. So we place alpha hydrogen in front so that they can be removed. This is beta. So we write it like this. So O from the aldehyde or ketone and H2 from the alpha carbon. That should be removed. It is not like that you will write it like this and remove the beta hydrogen. Then it is wrong. It is not the end carbon from where hydrogens are removed. It is the alpha carbon from where the two hydrogens are removed. So these are the two products which are simple products. These are the simple aldol condensation products. Now cross it. CH3CHO of ethanol and H2 is removed from propanol. So this is the cross product. So this is the first cross product. Now second cross product, take propanol, O from propanol and H2 from ethanol. So this is the second cross product. So these are the four products formed. If two different aldehydes or two different ketones, each of them should have alpha hydrogen, then we will get four products in all. We get four products. Okay? CH3CHO with CH3CHO, CH3CHO with CH3CH2CHO. Propanol with propanol, propanol with ethanol. So these are the cross products. and these are the simple products. So in this way we get 4 products in total. Now this one, this is one aldehyde. Now this is the second one. These are the two different carbonyl compounds. One is aldehyde, other is ketone, but first one has no alpha hydrogen. So in cross aldol, we can take one of the aldehyde or ketone having no alpha hydrogen, but one of them should have alpha hydrogen. So see, this one has alpha hydrogen. So H2 from this, O from this. So we get this one. Second product, that we can get is this one, but this is not formed in good yield. Reason being, there is a steric hindrance, and due to steric hindrance, this product is less than expected. Okay, so it is, the scene name is derived like 1, 2, 3. So 1, 3 diphenyl prop, 2 ene, and 1 one. So this is the IUPAC name, and its common name is benzyl acetophenone. Got it, beta? Aldehydes are more reactive than ketones. Reason being, in aldehyde, here on the carbon, there is one hydrogen attached to the carbon, which is attached to O by double bond. But in case of ketone, carbon which is attached to oxygen by double bond is attached to another alkyl group or aryl group. So there is a more steric hindrance, and therefore chances for the product formation is less. तो aldol condensation बेटा समझ में आ गया आपको?
Yes, sir.
Okay, great. Now come to the next part, that is the cannizzaro reaction. In cannizzaro reaction, we should have aldehyde which do not have alpha hydrogen. See, aldehydes which do not have an alpha hydrogen atom. See, in case of aldol condensation, we should have alpha hydrogen, but in case of cannizzaro reaction, we take those aldehyde, we use those aldehyde which do not have alpha hydrogen, and they undergo self oxidation and reduction, that is called disproportionation. Disproportionation means when same element or compound undergoes oxidation as well as reduction, and it is in the presence of concentrated alkali. See, in aldol there is a dilute alkali, second aldehyde or ketone having alpha hydrogen, but in cannizzaro we should have aldehyde having no alpha hydrogen. So one molecule undergo oxidation and another undergoes reduction. So see, C double bond O, H, H. C double bond O, H, H. In the presence of concentrated KOH, so what would happen? There is addition of hydrogen in first case. So two hydrogen remain as such. In carbon oxygen double bond, it becomes single bond. There is H, there is H. That is, alcohol is formed. In the second case, again one of the hydrogen is removed from here, double bond O and OK. That is, it is one is oxidized, other is reduced. So we get alcohol and a salt of a carboxylic acid. Same is the case in the next part. This is aldehyde. This is next another aldehyde. In the presence of concentrated potassium hydroxide, so one of the a carbon oxygen double bond that is replaced by two hydrogen atoms, and another case double bond O and H is replaced by potassium salt. So one is benzyl alcohol, another is potassium salt of carboxylic acid. Either potassium hydroxide or sodium hydroxide. One is benzyl alcohol, other is sodium benzoate. तो ये भी सिंपल है बेटा. क्या हो रहा है इसमें? समझ गए बेटा?
Yes, sir. Yes, sir.
Okay. Now, electrophilic substitution reaction. So, aromatic aldehydes and ketones, they undergo electrophilic substitution at the ring, in which carbonyl group act as a deactivating group. I think you know this benzene ring when attached to C double bond O. What is the nature of this group? What effect does it show? Plus R or minus R? CHO. CHO. What is the nature of CHO? Is it electron releasing or withdrawing?
Sir, can you repeat?
CHO. What is the nature of CHO? Does it show plus R or minus R? Which effect it has?
Electron withdraw.
Very good. Electron withdrawing. It is an electron withdrawing group and it will show minus R effect. So as resonance takes place and ortho and para only, so CHO withdraw electrons. As it withdraw electron, obviously it will withdraw electrons from ortho and para position. So where do the electron density left? A small amount of electron density left only at a meta position. That's why it is deactivating and meta directing. So it is meta nitrobenzaldehyde. So we will get meta nitrobenzaldehyde. ओके, ठीक है बेटा.
Yes, sir.
CHO is electron withdrawing group and meta, as it is withdrawing, so it is deactivating. Yes, it is written deactivating and meta directing, because if it is withdrawing electron by resonance, and resonance takes place at ortho and para position only, so in this way it withdraw electrons from ortho and para, so a small amount of electron density left at meta position, right? So it is a meta directing group. So it is, now use this in chemical industry. Both aldehyde and ketones, they are used as solvents and starting materials and reagents for synthesis of other products like formalin. Formalin is very important solution. It is 40% solution of formaldehyde, which is used to preserve biological specimens, and even it is used to prepare bakelite, that is a phenol formaldehyde resin. Even urea formaldehyde glues, other polymeric products. Acetaldehyde is used primarily as a starting material in the manufacture of acetic acid, ethyl acetate, vinyl acetate, polymers, and drugs. Benzaldehyde is also used in perfumery, in dye industries. Acetone and ethyl methyl ketone, they are common industrial solvents. Many aldehyde and ketones, butyraldehyde, vanillin, acetophenone, camphor, they are used, they are well known for their odors and flavors. But here, most important part is formalin. So keep in mind that formalin, first, what is formalin? It is 40% solution of formaldehyde, and it is used to preserve biological specimens. Okay, it is also used for urea formaldehyde resin or urea formaldehyde glues or bakelite. Bakelite. Okay, so that's all. Next, in the next lecture, we will start carboxylic acid. Okay, beta.
Yes, sir. Yes, sir.
ओके, सो यहाँ तक कर लेना बेटा, ठीक है.
Yes, sir.
ओके.